Hey everybody, it's Mr. Troy here. I've got a great video for you today about using the law of sines and the law of cosines. You think you're ready to do this? Alright, let's go. It's time for math with Mr. Troy. Alright, first thing we're doing is the law of sines. Everything we've done so far has been assuming a right angle, all of your SOHCAHTOA. So in order to apply that to oblique triangles, we need to figure out a way to compare ratios. And our first way of doing that is using the law of sines. So what the law of sines tells us is that there's a relationship between an angle and its opposite side. Now, not opposite in the sense of you need a perpendicular, just the side opposite of it in a triangle. But the issue is that this proportionality, this relationship, isn't just if you make the angle twice as big, then the side is twice as big. That just wouldn't work. So the way that they are in proportion is that the sine of an angle and that side are in proportion the same way that the sine of another angle and its opposite side are. Okay, that is called the law of sines, and I would guess that almost all of you have seen this in one way or another before, and you may have already used it at some point this year. When we're working in triangles like this, we're usually going to use degrees as our input, but there's no reason that you couldn't use radians. Now, the law of sines is always presented in that way of showing A and B and C, but you're really just going to use any two of those and do a cross multiplication problem. Pretty simple. So the first thing you're going to do when you're presented with a problem, I got a whiny puppy in the corner, hold on a second. Okay, we're going to try this again, and hopefully she doesn't whine because I don't want to have to do any editing. Okay, so the first thing you're going to do, and your impulse is going to be to not do this, but please do this. The first thing you want to do is you want to draw that triangle. So I have A, an angle is 28 degrees, B, an angle is 102 degrees, and A, the side is 8. So that triangle would look something like this, with this being somewhere like 28 degrees, this being something like 102 degrees, and this side being 8. So our A, our B, and our C. Now, you do have enough information to say that this is a, 50-degree angle? So you might as well label that when you've got the chance. My suggestion to you is that as you're doing these problems, just from the outset, you always say, okay, I need to find A and B and C. Those are angles, and little a and little b and little c, those are sides. I can fill in what I already know, so I know how well I'm doing, 28 degrees, 102 degrees, 50 degrees. If you set it up this way, you'll just stay organized. Okay? So set up your ratios, look at two only, and decide what you can find out. So what can we find out here? Well, if I'm thinking of this as a cross multiplication problem, a cross multiplication problem requires a fraction that has three parts, or I suppose two fractions, that have three parts filled in and one part missing. So I could do the sine of 28 degrees over 8 equals the sine of 102 degrees over b. And that's going to help me solve that using cross multiplication. Okay? When you're using your calculator, do make sure that you have your calculator in degree mode. If your calculator is in radian mode, it's not going to understand what you mean by 28. It's going to think you mean, some 7, 8 pi, somewhere around there. Okay, so make sure you're in degree mode. All right, so here's that work typed out. Again, In degree mode, you're just going to punch in that b is 8 times the sine of 102 degrees over the sine of 28 degrees, and you're going to get that b is 16.7. At this point, stop and do a common sense check. The angle 102 degrees is bigger than the angle 28 degrees. So make sure that b you just found is bigger than 8, side A. So make sure side B is bigger than side A because the angle is bigger, okay? Always make sure you check that. You would just follow the same process to find C. Now, notice when I set this up that I used A and A from the original problem as opposed to using B. The reason I would avoid using B is because B, that 16.7, is rounded, and I don't want to use a rounded number when I have an exact number available to me, okay? So always use that original side/angle. Okay, so I've got this set up the way that you would set it up using cross multiplication. And now I'm going to isolate C. And when I do that, I find that C is roughly 13.1. So we're just going to round to the to 1 decimal place in a problem like this. Check to make sure your smallest angle and smallest side match up, your largest angle and your largest side, and your middlest angle and your middlest side. Those have to go hand in hand, so do that common sense check as you're working. Since this is review, I'm just going to put a problem up here and give you a chance to pause the video and solve it. Then I'll put the answers up. You can totally ask questions about this in the Google Meet today if you have questions, but just a chance for you to do a problem. Here you go. All right, here come the answers. Now in this particular one, we don't need to follow the same process to find C, because we already know what C is. Come on, Mr. Troy, don't copy and paste everything. All right, moving on. Now the law of sines is pretty easy, but you do need to have one thing be true for it to work. You have to be able to set up a proportion. Now, in the problem preceding this, we were able to set up a proportion because we know that the angles of a triangle have to add to 180 degrees. So we could use simple subtraction to find C. Since we can find C, now we have the ability to do cross multiplication with either C and A or with C and B. There has to be a matchup, though, of the same letter. So angle C and side C, or angle A and side A, or angle B and side, what was it? Oh yeah, B. Okay. Now, if we don't have the ability to do that, then we need to use a separate law, the law of cosines. Okay, so the law of cosines is another way to connect sides and angles together. And it's my guess that you're familiar with this. So, for example, the way it's often given is a squared equals b squared plus c squared minus 2bc cosine a. Or, more commonly, this is what you'll see. Because it shows you how much you already know about this rule. Okay, a squared plus b squared equals c squared, except it's actually a squared plus b squared minus 2ab cosine c. So if the angle you're talking about is 90 degrees, the cosine of 90 degrees is 0. Well, why? Well, here's a 90-degree angle. Its cosine would be x over 1. Sorry, x over 1 if we were in the unit circle. Now, if we were in the unit circle, we would be able to very easily see that the x-coordinate would be 0. The y-coordinate would be 1. So the cosine of 90 degrees is 0. If that happens, all of this goes away, and we have the Pythagorean theorem. However, that's not always the case. Okay? So the way that I think about this is that the law of cosines is the Pythagorean theorem with a correction for what happens if the triangle is not a right triangle. So it looks just like the Pythagorean theorem. And then the way that I remember it is that it's a squared plus b squared minus 2ab. So the a and b are on the inside of the rule, and it's cosine c and c squared. Those are on the outside of the rule. You do need to memorize that for like all of math forever. Okay, a couple things at the start of this problem. Remember my suggestion of setting up kind of answer blanks for A, B, and C, and A, B, and C. That way you can write in what you know and what it is you're trying to find. Okay, so first thing, stay organized. Second thing, knowing that you have to use the law of cosines. Now, I'm sure you've heard this before, but just a reminder, the law of sines only works if you have that cross multiplication, that proportionality. If I tried the law of sines here, and I did the sine of b over 19 equals the sine of c over 14, I wouldn't have one unknown to solve for. I would have two unknowns to solve for. So when I don't have a matching letter, that's how I would know. This breaks down into kind of like two different triangle theorems, if you want to think about it that way. If the information that you have is what we would call side, 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 so in this case I know all three of the sides, or if alternatively the information that you had was side angle side. So think about it this way. If I happen to know that B was, say for example, 115 degrees, but I didn't know what little b was, I would have a different setup here. So I would still have, you know, something to fill in, but I wouldn't know what this information was. And I would again have two unknowns, and that's not something I could solve. So in cases of side, 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 or side angle side, I'm going to use the law of cosines. Okay, I'm going to get rid of this kind of other problem here for a second, and then we can go back to doing this one. Okay, when doing the law of cosines on a side, side, side triangle, you want to start by finding the largest angle first. Now, we haven't learned about the law of sines ambiguous case yet. The stuff we're doing is ignoring that for now, but we will learn that. The reason you want to use the largest angle is to avoid the ambiguous case if you were to use the law of sines later on in the problem. So, some people use the law of cosines and then use the law of sines. You can avoid a tricky situation if you find the biggest angle first. So we would set that up like this. 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the times the cosine of b. Okay, you can set it up that way, or if you wanted to, you could use this alternate cosine formula, but I never really do it that way. I always just end up deriving it anyways. Okay, now one thing that I want to make sure you're aware of is that this right here is all connected. So you can't just multiply this out. If you were to multiply that out, you would get 16 times 14, which is negative 224 when you consider the negative sign. So you would have this. You can't just add 224 to break these up. You need to subtract 8 squared, and you need to subtract 14 squared. Then you need to divide by negative 224. And I'll show you what that looks like. Okay, so if you subtract 64, and then you subtract 196, you're left with 101 equals negative 224 cosine B. You're going to divide by negative 224. So I want you to think about how this would work out. You get cosine of B equals negative 101 over 224. Remember, cosine is positive in the first quadrant, so this means that angle B has to be in the second quadrant. When we plug that in, we would do the cosine inverse of negative 101 divided by 224. Oh, I'm in radians. I got 2.03, so I forgot to put my calculator in degrees. I need to multiply by 180 and then divide by pi. And I get that B is about 116 degrees. And I'll go to one decimal place, so 116.8 degrees. So remember, to get B, you're doing the cosine inverse of 101 over 224. Now, you've got options. From here, now that you know what angle B is, you can use the law of sines if you would like, or you can just use the law of cosines. You can use the law of cosines 3 times if you want. No reason you couldn't. So here's my suggestion. Go through, work through the rest of this problem. Either use the law of sines or the law of cosines. I'm going to put the answer up in just a second. Okay? Ready? Here it comes. All right. So we did get that 116.8. And then we get that A is 22.1. Since we know that A is 22.1, we can just subtract from 180, and that'll get us our last angle. All right, folks, I hope that video helped. You'll have some WebAssign over this, and plenty of time to ask questions. All right, hang in there, everybody.